In example 9, section 6.4, we want to graph the function not by plotting points, but by starting from graphs in the figures below, then plotting the points. Okay, so the graph it's given is h of x, which is equal to the natural log of x plus 4. So what we need to do is graph the parent function to this. Well, the parent function is the following. We have f of x, which is equal to the natural log of x, and what you can see here is in green. So once I graph that, let's say that I graphed it on Desmos, what I'm going to do is I'm going to go ahead and then look at some points on that graph. Well, we know that it passes the x-axis at 1, 0. And then over here, I'm just estimating. We know the value here is 5 for x, and this is about a little bit above 1.5, so it's 1.6. Again, I'm just getting a general idea of what that looks like. Okay, and then here we also have a point. So we have 10, and it's approximately about 2.2. So there are our points for the parent graph. Now, given a logarithmic function with that form, we want to be able to graph the translation. Now, in this scenario, we have x plus c, and the value of c is 4. Now, if c is greater than 0, then we're going to shift the graph left units. If c is less than 0, then we're going to shift right c units. So we can see that the value of c is equal to 4, and we know it's going to be greater than 0. So that means we're going to be shifting to the left 4 units. Okay, and then we're going to draw the vertical asymptote. And the vertical asymptote is x is going to equal the negative value of that c. So the value of c is 4, so we're going to see that the vertical asymptote is x equals negative 6. And then we're going to identify 3 key points from the parent function, which we've done. And then we're going to find new coordinates for the shifted functions by subtracting c from the coordinate. And then we're going to label those 3 points and then determine the domain and range in the vertical asymptote. Okay, so if you take a look at this, we have step 1. We know that our function is h of x, which is equal to the natural log of x plus 4. We see that our base here is e, and the value of c is equal to 4, which is greater than 0. So therefore, we're shifting the graph 4 units to the left. And now the vertical asymptote at x equals negative c, so x is going to equal negative 4, and therefore over here you can see our vertical asymptote. And then we're going to take our ordered pairs from the parent function and then use the value of c to then find our new coordinates. And since the value of x is what's being manipulated, the y's are going to stay the same. So the value of 1 from the parent function is the x coordinate. We're going to subtract 4, and the y value is going to stay the same. So we end up getting negative 3, 0. So there is one of our new ordered pairs. The next, we have 5, 1.6. So we're going to take 5, subtract 4, and then leave 1.6 alone. So we end up getting 1, and then 1.6. And then the last one, we have 10 and 2.2 from the parent function. So we're going to take 10 and subtract 4 and leave the y value alone. So we're going to get 6 and then 2.2. And then you can see those points on the graph because then we're going to go ahead and plot those points. Now we're going to state the domain and the range. Well, the domain now, since the vertical asymptote starts at negative 4, so we're starting at negative 4 and then going all the way to positive infinity. And then the range is going to be from negative infinity to positive infinity. And then this state the asymptote, well, the asymptote is x, which is equal to negative 4. And so therefore, here would be our final answer.